Hello and welcome to another Maths with Harry lesson. In this video, we're going to be having a look at expanding and factorising brackets. So, I'm going to delve straight into the book. What we want to do when we expand brackets, and you've probably seen this before, but expanding brackets means multiplying everything inside the first bracket by everything inside the second bracket. Now, what we generally mean when we say expand is, and I'm going to quote this straight from the book, when we want to find the product of two expressions, expanding means multiplying each term in one expression, so in this case in one bracket, and I'll put that bracket, by each term in the other expression. And again in the other bracket. So keywords in that definition there are, well, we want to multiply each term in one expression by each term in the other expression. Okay, so multiplying everything in the first bracket by everything in the second bracket. Or if you've got three brackets, multiplying everything in the first bracket by the second and the third, and so on. I'm going to get on to what factorising means in a minute, and I'm going to demonstrate expanding brackets by examples. So here are 4 examples of expanding brackets. Press pause and have a go if you want to, and then we'll work through the answer. Hopefully, if you press pause, you've had a go. Let's have a look. So, what we want to do, like the definition I just said, is multiply everything in the first expression, and the first expression I'll highlight in green, by everything in the second expression. And the second expression I will highlight in blue. So the green is the first, the second is the blue. Now you might have remembered, maybe from GCSE, if I introduce these arrows, what we do is we multiply along these arrows in order to multiply everything in the first expression or bracket by everything in the second bracket. So we multiply along those arrows. Now I'm going to do this quite quickly because you probably have seen this at GCSE before. So if we multiply along this bracket first, I'm going to get x times x, multiplying along the bracket. X times x will give me x squared. Then what I'm going to do is I'm going to multiply x by the 2, because I need to multiply each term here by each term here. So we'll do the x first. We've done the x with the x, so now we need to do the x with the 2. And when I do that, that will give me plus 2x, because remember, 2 multiplied by x, or the other way around, x multiplied by 2 doesn't matter. Multiplication is commutative. That's another word that you might not have seen before. We can multiply both ways. That is 2x. We don't need to write the multiplication sign. Okay, so I've multiplied the x by everything in this bracket, and now what I'm going to do is multiply the 5 by everything inside the blue bracket as well. So we'll do the 5 times the x along this little bracket here to give me plus 5x, and we just add it on to what we've already multiplied and expanded, and then the 5 multiplied by the 2, and that will give me 5 times 2, which is 10. Now don't leave your answer like this. You can do, but it's not in its simplest form. I didn't ask for its simplest form here, but what I really should have done is said multiply and then give it in its simplest form, because that's what you're really required to do in the exam. So what we need to do is we need to collect like terms, and collecting like terms basically means, well, there I have an x, and here I also have an x, and what I've actually got is 2x and 5x, so I can add those together. If I've got 2x and then another 5x, in total what I've got is 7x. And that is our final answer. We can't simplify that any further because none of the terms are able to be collected. Alright, let's have a look at the second example. Now here, we've only got one bracket. We've got one bracket squared. Now remember from indexes, when we square something, what we actually mean, and I'll write this in black because what I could have said is x minus y times x minus y. That's what we're really doing. We're multiplying x minus y by itself. And now all we can do is do the exact same thing. So we can multiply along those arrows there and multiply along those arrows there. Now you don't have to draw the arrows in every time. I'll just do it for these first two examples because it's going to make it easy and visual for us. Okay, so I'm going to multiply the x with each term in here. So the x with the x will give me x squared. And then I'm going to multiply the x with the minus y. You have to take the sign with it when you multiply. So what we're actually doing is x times minus y. And then remember, that is minus xy. Because a minus times a plus, there's an invisible plus sign here, gives us a negative. Okay, so we get minus xy, and then what I get is, well, I need to add on what I get when I multiply each term here by the second term, which is minus y. Again, we need to take the sign with it. So minus y times x, that's going to give us minus xy. And notice how I write my letters in alphabetical order. That's just something that I always do. It's neat, it helps us. So always write your letters in alphabetical order. So we've done the minus y with the x, and then we need to do the minus y, multiply that by the second term, which is minus y. And I can just fit that on there. We've got a minus times a minus will give me a plus, and then y times y is y squared. Then we'll have a look. We've expanded now. Can we do anything with our answer? Can we collect like terms? Yes, we can collect those terms there. They are both xy terms. We've got minus xy, and then we're minusing another xy, minus, and then minus another one. So I will have x squared minus 2xy plus y squared. And that is our final answer. Now, the more of these you do, the easier it is to actually be able to expand. You don't really have to do all this working out here. What you can do is just go from that straight to that. And the more you do, the better you'll get at these. So it's just practice. Okay, so I'm not going to draw the arrows for these next two examples. We're just going to have a go at them. I'm going to multiply the 2x first of all, so I'll highlight that. Multiplying the 2x, I'll do the 2x with the x to give me 2x squared. And then I'll do 2x with the minus 4. So I've done it with the x, now I need to do it with the minus 4. And that will give me minus 8x. I've done the 2x now, so now in red I'll do the minus 3. So in fact what I could do is I could make that a green colour. If we make that green, I'll then do my answer here in red so that it corresponds with the colours I've highlighted. Okay, so we need to do the minus 3 times the x, so that will be minus 3x. And then I need to do the minus 3 with the minus 4. So we need to do minus times a minus, which will give me a plus, and then 3 times 4 will give me 12. And then we're going to go back to my blue, and I can collect like terms here. I've only got 2x squared, there's no other terms with an x squared, so that will just give me 2x squared. And then I've got minus 8x minus another 3. Remember, that's going to go further down the negative, so we're going to have minus 8, then minus 9, minus 10, minus 11. So we'll have minus 11x, and then we've just got this constant on the end, just this number that we're adding. So we'll add on 12, and that will be our final answer. You can always check your answer, so we can have the 2 times the x, yes, that gives me 2x squared, 2x times the x, then the 2x and a minus 4, minus 8, then minus another 3 will give me minus 11, and there was an x, and then multiply your constants. Another way to check your answer is to factorise all of these, and we'll move on to factorising after we've done this example. So what's different about this one? Well, we've got 2 brackets here, but in this first bracket, we've got 3 terms. Now, just going back to the definition, all we need to do is we need to multiply each term in one expression by each term in the other expression, or in this case, brackets. So we need to multiply every term in this bracket by every term in this bracket. Now you probably had a go at this, you might have been able to do it, but I'm going to do it with no arrows. I'm going to multiply the 5x by everything in that bracket first. So we're going to have 5ax and then minus 5 times 4 will give me 20, and then we'll have an a on the end. Multiplying with the 5a and the x minus 4 complete. So let's get rid of that. And now what we're going to be doing is we're going to be doing the minus 2, and it's minus 2b with everything in that bracket. So I'm going to take the negative with it. Minus 2b times x will give me minus 2bx. And then minus 2b times minus 4 will give me plus 8b. Let's double check we've done that correctly. Minus 2b times x will give me minus 2bx. And again, writing those in alphabetical order. And then the minus 2b times the minus 4 will give me positive 8b. Then what I need to do is I need to get rid of the highlighting, and I need to do the 3 with the x minus 4. And I'm just going to multiply each term by 3. So I'll have 3x minus 12. And then we can collect like terms. Now, are there any terms that we can actually collect here? Well, this term has an ax, and there's no other term with an ax. This term has an a. I suppose we could maybe take out a factor of a here, but we haven't really done factorising yet. We'll get onto that in a minute. So I'm just going to leave that exactly how it is. We will leave that like that because it actually hasn't asked us to simplify, so I suppose that's a perfect example of factorising, and we'll just get rid of the highlight there. Okay, now I'm going to, actually I'll scroll down here because this is where the definition of factorising comes in. We can factorise in 3 ways, and it kind of depends on what you're given. So, I am just going to move this down. The first way is to look at common factors, and I'm just going to hide those examples. The first way, like I said, is to look at common factors. And when we want to factorise something, what we want to do is we want to express the things as a product of their factors. And what that means, a product means to multiply, and we want to take out factors out of the front so that we can multiply by their factors, if that makes sense. You probably have seen this before, so that's why I'm explaining this to you. But that's the first way. So common factors is the first way we can do this. The next way we can simplify is when we've got them in the form, and we're looking at quadratics here, we've got quadratics in the form ax squared plus bx plus c. And you probably know the method of that, we'll refresh it in a moment. Then the third way, we can get rid of this box now, is to look at the difference of 2 squares. And I think I have an example of the difference of 2 squares. Oh no, I don't, so we'll have a look at that at the end. Okay, let's have a look at the example of common factors. I have 4 of them, so press pause and have a go if you want to, and then we'll work through the answer. Hopefully you've paused the video now. Let's have a look and see what we can do. So we're looking here at taking out common factors. Now you've probably done this before, maybe factor trees at GCSE, but what we want to do is we want to look at the biggest number that goes into both of the terms. Now sometimes it might not always be a number, we might have letters in each term that we can factorise out as well, but in the first case for part A, we can factorise this by pulling out a factor of 3. The highest number that goes into 3 and 9 is 3. So what we can do is we can factorise out of 3 and then think, right, I've divided this term by 3, so to make it 3x, what I need in the bracket here is an x. So that when I then do the opposite, which was expand, I expand that, we get the 3 times the x, which gives me 3x, like we started with. So I'm going to factorise out of 3 to give me 3 times x. And then this term here, what I need to do is divide that term by 3. And when I do that, that's plus 3. So we get 3 times x plus 3. And because we can check our answer and do the opposite, we can expand that bracket. When we do get 3x plus 9. So we know we've got the right answer. So that's our final answer there. All right, now let's have a look at B. For B, we don't just need to factorise out a number. We need to factorise out a number and a letter. So we actually need to take out a term. And the highest common factor of 8 and 4, highest common factor you should have seen at GCSE. We want to divide both of those by the biggest number that we can divide by. And we can divide both of those by 4. Now I could divide them by 2 and then take out another 2, but taking out the highest common factor is the best way to do it. So we'll take out a factor of 4. So then what we need to think is, well, what I've actually done is divided both terms by 4. So we need to divide this term by 4, and when we do that, that will give me 2x squared. We'll expand that bracket a little bit. And then we need to think I've divided this term by 4. And when I do that, the 4 will cancel here. So I'll just get plus xy. But if I have a look at what's inside my bracket still, it's not factorised to the fullest, if you want to put it that way. We can still take out a letter from both terms. And the reason we can do that is because this term here has a factor of x, because we're multiplying that term by x, and this one has a factor of x squared. So the highest common factor of both of those is x, because this term here has x squared, and this term here has x squared. If that was x squared y, we could take out a factor of x squared from both terms, but it's not. This term here has just got 1x in it. So all we can do is take out a factor of x. So we'll go back to blue. That's going to give me 4 times x times 2x plus y. Okay, so the difference there is that we just took the factor of x out. And then when we actually expand those brackets again, we can check our answer. And when we do that, we can see if we were to multiply along these arrows like that, I would have 4x times 2x, which would give me 8x squared. And then I'd have 4x times the y, which would give me 4xy. All right, let's very quickly do these next ones. In C, all we could do is take out a factor of 11x from both terms. Oh, no, 11y from both terms, sorry. We've got y's in both terms. So what we'd have is we would have 11, because both 11 and 33 are divisible by 11, and it's the highest common factor of both terms. So we can take those out there. And then we can also take out a y from both terms to give me 1 plus 3x, and that's our answer there. If we have a look at D, well, I can take out a factor of p, because we have a p squared here and we have a p, and I can also take out a factor, well, I could take out a factor of 2 and I could see how that goes, or I could notice both of these are divisible by 4. I could take out a factor of 4 and have a p as well, 4p. If I take that out, well, let's think, what would that give me? If I take 4p out, what I would have is I'd need to divide this term by 4p. And when we do that, I'd be left with 3p, because 12 divided by 4 is 3, and then p squared divided by p is just 1p. And then what I would need to do is divide this term by 4p. And when I do that, I would get, write that a little bit neater, plus 5. And when I check that, if I expand, I'd be expanding across the brackets, across the arrows like that. And I would get 4p times 3p, which would give me 12p squared. And then plus the 20p, and I'd get that from 4p times 5. So that's our final answer there. Okay, now we're going to have a look at what happens when we've got them in the form where we have x squared minus some x minus some constant. So we've got some coefficients here, a, b and c. And I should really write here where a, b and c are given in the question, okay? So let's have a look at the first one. I'm going to demonstrate what we need to do again by examples because I think that's the easiest way. What you want to do is you want to find two numbers that, in the case where you just have, remember, there's just a little 1 in the front here. In the case where you just have the coefficient of x squared to be 1, you want to find two numbers that multiply together to give c. So in this example here, that's minus 6. And add to give you b, minus 5. So we'll write that here. So when we've got a to be equal to 1, we want to find two numbers that to c and to give b. So what I do at the side here is I say, right, for example A, we want two numbers that multiply to give me minus 6 and add to give me minus 5. So we can think about the factors or the pairs of numbers that multiply to give me minus 6. So always start with 1. 1 and what number multiplies to give me minus 6? Well, that's 1 times minus 6. Now 1 times minus 6 times to give me minus 6. And it also, if you add those two numbers together, 1 plus minus 6 does give me minus 5. So those numbers are what I'm going to use. So I'm going to have my brackets here, and I set up my brackets like this. We've got 1x squared, so I need two brackets like that, and I'm going to have x at the front of those two brackets. The reason I do that is because when I actually expand my brackets in a minute, if I wanted to check my answer, I'd expand across that arrow and I'd get x squared, which is exactly what we need. Okay? So let's just get rid of that arrow for the minute and let's think about what numbers are going to go in there. Well, the numbers that go in there are these numbers here. So we're going to have plus 1 and minus 6. And that is your final answer. What we have done is we have took this quadratic here, because it's a quadratic, because it's a power 2, we've took that and we have simplified and factorised the brackets. And then if we look, well, here, when we were expanding brackets, it's the exact opposite. Here we were expanding them to give us our quadratic form. When we factorise, we go back and we want to put it into brackets. Let's have a look at this example here. This one differs slightly. We need to manipulate our statement down here. When a does not equal 1, so I'll write equals with a slash through, that means does not equals. When that's the case, we need to find two numbers that and we do a times c. We multiply a and c. Now we actually were doing that in this case because we had minus 6 and 1. So we wanted two numbers that times to give me minus 6. And very simple, then they need to b. Hopefully that's clear. So let's write our numbers down here. So we need two numbers. Add to give me what? Well, they need to add to give me a times c. This is a here. And that is c. We take the sign with it. So we need two numbers that times to give me minus 60. And then we need two numbers, the same, that still add to give me minus 60, but times or multiply to give me b. So that is going to be in red, and b is minus 11. Okay, let's have a think. What are we going to need to do? Well, we need to go into list the pairs of numbers that times to give me minus 60. So I'm going to start with 1 and minus 60. That definitely does not add to give me minus 11, so let's go to 2. 2 times what gives me minus 60? Minus 30. 2 times minus 30, that works for the multiplication, but for the addition, it does not give me minus 12. So actually, that's not going to work. I'll put a red line through that, and a red line through that. That's not a good idea. Move on to your next number, 3. 3 times what gives me minus 60? It is 3 times minus 20. Okay. Now, is that going to work? Not for the addition, so that's not what we want. Move on to your next number. Sometimes you might be able to spot it straight away, but it's always good to really break down and think 1, 2, 3. No, doesn't work. Let's try 4. 4 times what gives me minus 60? It's minus 15. Now I'm going to stop there because 4 times minus 15 does give me minus 60. And when we add those two together, 4 minus 15 does give me minus 11. So that's perfect. I'm going to use those pairs of numbers. So what's a little bit different here as well, in this last example, we wanted to, when we expand our brackets, kind of in our head to check our answer, to get x squared. So here, what I'm going to write is, I'm going to write 6x, and I'm going to do that at the start of each bracket, okay? Now notice what we do when we do that. If we multiplied those out, we would get 36x. We don't want that. So in a minute, we need to do a little bit of division. I'm going to put those numbers in, so 6x plus 4 and 6x minus 15. And then what I'm going to do is I'm going to treat these two brackets separately. So if I get some colours here, we will have a purple and we will have a green. Okay. Looking at the purple bracket, I'm going to focus on the two terms, and I'm going to divide each term by the biggest number I can divide by. The biggest number, or the highest common factor, of 6x and 4 is 2. So I'm going to divide both of those brackets by 2 to give me 3x plus 2. I can't divide those terms by anything else. There's no common factor of 3x and plus 2. So that bracket is finished. We've finished with that bracket. Then we need to think about what can we do with this bracket here. And I'm going to again divide by the highest common factor of both terms. Now just ignore the negative here for the minute. That will just carry down. We need to think, what's the highest common factor of 6x and 15? I can divide both of those terms by 3. Because when I do that, 15 is in the 3 times table, we'll get minus 5, and 6x divided by 3 will give me 2x. So divide both of those by 3 will give me 2x minus 5. And I can't do anything else with that bracket, that's just as it is. 2x and minus 5, I can't have a common factor of both of those terms. So that is my final answer. That is exactly what I get when I factorise this quadratic here. Okay? And then if you wanted to expand that, well, let's think about what we do. We do the 3x with the 2, and then the 3x with the minus 5, and then the 2 with the 2x, and the 2 with the minus 5, and you can check for yourself that that works. Okie dokie, let's have a very quick look at C and at D. So C, we just need to find two numbers that times to give me 8 and add to give me 6, because there's a 1 in front of that there, so we don't need to do the multiplication. And I can think, well, 1 times 8, no, that doesn't work. 2 and 4, that multiplies and it adds to give me 6. So we're going to have x plus 2, x plus 4. And that's, oops, that is your final answer. Having a look at D here, we need to do one step before we do our normal factorising. I'm just going to move this down a little bit. What we get here is I can notice each term has a factor of at least x. Here we've got x, here we've got x squared, here we've got x to the 3, or x cubed. So what I can do is I can factorise an x out of each term. So when I do that, I'll take an x out, just like I was doing with these questions here. I can take out an x to give me x squared plus 3x minus 10, and then have a look at what's highlighted in green. Well, I can just factorise that like normal. So I'm going to end up with the x, and then I'm going to have a bracket with an x, and we'll leave that blank for a number in a minute, and we'll leave that blank for another number. So now all we need to do is we need to find two numbers that times to give me minus 10, or c, and add to give me 3. So when we do that, well, let's list our numbers. We're going to have 1 and minus 10. They times to give me minus 10, but they don't add to give me minus 3. Let's just do that, oops, a little bit neater. Perfect. Okay, then we need to think, right, well, let's have a look at 2. 2 times minus 5 will give me minus 10. And then what I need to think is, well, do they add to give me 3? They don't add to give me 3, they add to give me minus 3. And when that's the case, that's not going to work, but what I can say is minus 2 and 5 times to give me minus 10 and adds to give me 3. So I'm going to use that pair of numbers. So I'll have x minus 2 and x plus 5. And that is your final answer. Okay, let's have a quick look, and I don't have any examples here, so I'll have to write some down, at the difference of two squares. Now, the difference of two squares is kind of in the title, really. The difference of two squares means we are subtracting two square numbers. So, for example, x squared minus y squared. That is the difference because we are subtracting, and it is the difference of two squares because x squared is a square number and y squared is a square number. When we factorise that, what we want to do is we want to get it in two brackets, but notice we've got no term in the middle. We've just got an x squared and we've just got a y squared. So whenever we factorise that, and I'll say equals, but I'll write underneath, oops, factorising. When we factorise, what we get is x plus y, x minus y. And what you want to do is you want to recognise that in any of your maths papers. You probably recognised it at GCSE maybe, but that is the difference of two squares. So we can think about expanding that. I'll do this in a grey up here. So x plus y, x minus y, we'll have the x times the x, which will give me x squared. We'll have the x times the minus y, which will give me minus xy. And then we need to do the y with everything, so we'll have a plus xy, and then we'll have a minus y squared. And then those red terms there will just cancel out because we had a minus xy plus xy. And as you can see, we're just left with x squared minus y squared, which is what we started with. So let's have a think. If we wanted, and I'll do 3 examples, I'll do it in black. Let's say we wanted to factorise, and we wanted to factorise x squared minus 25. Well, is this the difference of two squares? Yes, because it's come under this topic. But if we think about this as just a whole, if this was just given to you in terms of an exam, or it was in a bigger question, then yes, that is a square number. So that works as a nice square number. And then 25 is also a square number, so 2 big green ticks. So what that means is we can just put that in what we know? Well, it's going to be x and then plus, well, we had y, didn't we, when we had y squared? And here, y squared is just 25. So we're just going to have plus the square root of 25, which is 5. And then x minus 5. And if you were to expand that, that's exactly what we would have here, because the middle term would cancel out just like it did here. So really what we do when we've got a number is we say, well, x squared, we want x and an x, and then minus 25 we will get by square rooting and having different signs. Okay, let's have a look at another example, and I will pull one out of the book. We'll have a look at 4x squared minus 9y squared. So pause and have a go if you want to have a go, and we will factorise that expression. So what we're going to do is we're going to check whether we can use this difference of two square method here. We need to check, have we got a square number minus a square number? Well, we've got 4 times x squared. 4 is a square number and x squared is a square number. So this is a square number. That's perfect. So we can write 2 brackets and we can say, well, the square root of 4x squared, just like we square rooted x here to give us x squared to give us x. We need to square root this and that will give us 2x. And in the other bracket, we also need a 2x so that when we expand, and I'll do that in red along there, that will give us 2x times 2x, which will give us 4x squared. And then we need to think, right, is this a square number? Well, yes it is, because 9 is square, and so is y squared. And so we're going to have a plus and a minus, and then we're just going to think what multiplies by itself to give us 9y squared. Well, square root, we will get plus 3y, and sorry, that should be minus 3y. And we could check whether that works, and checking against the answer, that's exactly what we should get. Let's do one more. Let's have a look at, and we'll do a little adaptation of this one here. Let's factorise, and we'll factorise x cubed minus 25x. Now, when we want to factorise that, I can see straight away that there's a common factor in both x cubed and 25x, and the common factor is x, because there's an x and there's an x hidden in that x cubed. So straight away I can factorise out an x to give me x squared minus 25. Right, then, well, we've already done that in part A. We can see there in part A that we factorised to get that. And so all I need to do is just multiply that by x. So we know that x squared minus 25 simplifies to that, and then multiply the x on the outside. And I should have highlighted that in yellow, and also that in yellow. So hopefully now you can expand brackets and you can factorise when we can take out common factors, when we can use the quadratic form, and when we can use the difference of two squares.